Points E, D, and H are the midpoints of the side of the triangle TUV. Now, if you know that UV is 80, UV, this side here, is 80, and TV is 100, and HD, this small side here, is 80. Now, find HE. Number 15 now. How can we find the length of HE? Before that, HE, which side is parallel to HE? VU, bravo.
Yes.
So its length will be half the length of VU. Now, what is the length of VU?
80.
80.
80.
So the length of HE will be 40. Now the second one, number 16, sorry. Find ED. Which side is parallel to ED?
TV.
TV. So half TV. So half. What is the length of TV?
100.
100. So the length of ED will be 50. Now, let's find number 17. Number 17, we need to find the length of TU. What is the length of TU? Since that HD here is 80.
160.
Now,
Yes, Miss, 160 equal to you.
هلا TU is parallel
To HD.
So HD is parallel to TU. So HD is 80, half TU. Then, as we said yesterday, multiply both sides by 2.
Equal 160.
160.
160 equals TU. The last one now. So TU is 160. Now they've told me to find, so if this is 160 and E is the midpoint, which bisect or which cut the side into two equal halves. So what's the length of TE will be?
80.
80, bravo. Which is half of 160. Do you have any question?
No, thank you, teacher.
No, Miss. No, Miss, thank you.
Now here. Number 22. Find the value of x. Here you have this triangle. Here they told me that x minus 4, the side of the mid-segment of x minus 4 is parallel to the side 17. So what is the value of x? And since it's parallel, so means like the length of x minus 4 is half the length of 17. Do you know why?
Yes, Miss, because it is the mid segment of this triangle.
It is the mid segment, so this length will be half the length of the side. Then, so x minus 4. Now, what's the half of 17?
8.5.
It is 8.5. So plus 4 plus 4. So x will be 12.5. Do you have any question?
No, teacher. Thank you.
No, miss, thank you.
Let's go now to the second lesson. Today now we are going to start the lesson 2, which talking about perpendicular and angle bisectors. Perpendicular and angle bisectors. In this lesson, we are going to use the properties of the perpendicular and the angle bisectors. Let's say here, there's a special relationship between the points on the perpendicular bisector of the segments and the endpoint of the segment. Now, you remember before that if you have any line, for any line that you draw it here, you have three things. You have a points at the ends. We call them end points. And we have a point in the middle. We call it midpoint. And if we know that, if we have a ray that's drawn from a point, cut the line. Just a second, please. So if you draw a ray, cut the line in the middle point. Okay, the ray that's past the line in the middle point, this ray, we call it the bisector. Why we call it the bisector? Because it's perpendicular on the line and it's cut the line into two equal halves. Now then, so here we have this ray, which name it like CD. This CD here, this ray is perpendicular bisector of AB. Now they told me that if there's a line that has two endpoints and there's a ray that's come and cut the line into two equal halves. They told me here now, if you bring a side, starting drawing it from that point to the end point, and a side from this point to the end point, they tell me that the length of this side will be equal the length of this side. Like here, CA will be equal to CB. So if there's a ray, cut the line segment into two equal halves. From that point, if you draw a line to their endpoints, you will make the sides of a triangle. These sides of this triangle, their length will be equal. How can you prove that? As you remembered, in chapter 4, if we have this side, what do you call this side? Come on.
Which one?
Side, the blue one, I draw it now. Come on, side. No, here, come on. And since the ray bisects AB, so that's mean the length of this side will be equal the length of this side. And these two angles are equal. So what do you have here now? Side, angle, side. So since we have SAS, side, angle, side, means here that the two sides are the same or are congruent. The equivalent angle are congruent. The common sides are congruent. So I can prove that these two triangles are congruent. And since they are congruent, so it means the length of this side will be equal the length of this side. Is it clear?
Teacher means here side it must be congruent to the other side and like this. The same for the angle and the same for the side, the second side.
Yeah.
Yes.
Here this ray is cut the bisector into two equal halves. So if I want to prove now that these two triangles are congruent, triangle ACD and CDB. Let's prove now that they are congruent. Okay, what do you say? The first one, that CD is a common side. And this angle and this angle are congruent. And since it is bisect the side or bisect the base, it means here the length of this side will be equal to the length of this side. So here what did you have? You have side, angle, side, angle, side. So can you say that a triangle of ACD is congruent to CDB because of SAS?
Yes.
Yes.
Okay. Now, since we said that they are congruent, congruent means that I can say now that any angle or any side are congruent. If I prove by side, angle, side that the two triangles are congruent, that means any of the other angles or any of the other sides are congruent. So what does it mean? It means here like the length of this side will be equals the length of this side. Now let's go to our theorem here and in order, or let's repeat, what did we say here? Look at me here. If you have a ray PM and this ray bisect a side AP. So if the ray PM bisect the side AB and cut it into two equal halves, if it is bisected perpendicular on it, cut the line into two equal halves, so that's mean if you draw now two sides from that point to the A and from P to the other end points, they will be equal. So if PM is perpendicular on AB, so PA will be equal to BP. Is it clear?
Yes, miss.
Yes, teacher.
So I'll repeat. If the ray PM is perpendicular to the line segment AB, since it is perpendicular, so it's cut them into two equal halves. So MA will be equals to MB. And since MA is equal to MB, and since the bisector is perpendicular on the AB, so I can conclude that the length of BA will be equal to the length of BB. This is our second theorem here. If a point and the perpendicular bisector of a segment, then it is an equidistant from the same points of the segments. And this theorem, it has a converse. It has an opposite. The opposite says that if there's a point outside, or I can say out or far away from the line, and the distance from this point to the end points are equal, so it means like if you draw a line, so it means if you draw a line passing from that point cut the side, this line will be the bisector. The first one, they told me that there's a line, there's an array that will be perpendicular bisector on the line and cut it into 2 equal halves. So if you draw 2 lines from that point to the end point of the line, they will be equal. Here, no. Here they told me that if you have a side and there's a point far from this side, and if you draw 2 lines from that point to the end points of the side, and after you draw them, you find that they are equal. So it means if you have a bisector that you draw it from that point, cutting the line, it makes them equal and it will be perpendicular on them. Is it clear?
Clear,
Yes,
teacher.
teacher.
Yes, teacher.
Can you repeat the converse again?
Yes, Miss. Repeat it one time.
Okay. That's right, the
Yes,
theorem. Sorry?
Yes, Miss. The second one, the converse.
Okay,
one.
let's talk about the theorem first. I'll repeat the theorem. The theorem says that if you have a line, and for this line, there's a bisector, cut the line into 2 equal halves. And perpendicular on it. That's mean if you take any point on this ray, match it with the endpoints. Where's the endpoints? Here are the endpoints. If you match it with the endpoints, the length of this side will be equal to the length of this side. This is our theorem. Now, the converse says that if you have a line and you have any midpoint out from the line, and if you draw now, for this line first, you know that there are 2 endpoints. If you draw now the line from this endpoint up to this point, and another one from this point up to the endpoints, and after you draw them, you will, if you find that the length of this side is equal to the length of this side, it means here if you bring a line that's come from that point, bisect the side, it makes them equal and will be perpendicular on them. The previous one, if the line is bisector and cut them into 2 equal halves perpendicular on it, so the distance from that point will be equal. Here, if the distance are equal, so for sure the line will be perpendicular and cut them into 2 equal halves.
Okay, Miss.
Is it clear now?
Yes, Miss.
Yes, Miss.
Yeah. Now let's use the theorem. For this theorem here, what did we have? We need now to find the length of AB. This one. We need now to find its length. Now, in order to find it, let's look at me here. Here, as you say, where is my perpendicular bisector? It's BD. This is my perpendicular bisector. So BD is a perpendicular bisector. As you see here, it is perpendicular on the side and it cuts into two equal halves. So since it is perpendicular and cut it into two equal halves, what can I conclude?
That
The point from,
so
if there's a point,
yes.
the point on this bisector will be have an equal distance, sides matching the two endpoints.
So AB equal BC.
Bravo.
4x equals 6x minus 10.
So we can conclude here that AB equal to BC. Since BD is a perpendicular bisector, cut it into two equal halves and perpendicular on it. So I can say that these two sides will be equal. So 4x will be equal to 6x minus 10. Then here we have it as two equations. So negative 2x is negative 10. So x will be 5. Is it clear?
Yes, miss.
Now then, what did he want to find? Or did he ask me to find? They asked me to find the length of AB. So don't stop here. You find x. But what did I want you to find? I want you to find AB.
It's going to equal 20.
Bravo. Since AB is 4x, so it's supposed to be 4 times 5, which is 20. So the length of this side will be 20. And here, 6 times 5, 30 minus 10, it must be 20. Is it clear?
Yes, teacher.
Yes,
Yes,
teacher.
miss.
Yes, teacher.
Okay. Let's solve now another one here. Here now, look at SQ. Can you say that SQ is a perpendicular side or perpendicular ray on PR? Is it perpendicular?
Yes, miss.
Yes, teacher. It's perpendicular.
Does it cut PR into two equal halves?
Yes. Yes, teacher.
Yes.
So yes. So P, what it was here? Sorry, just a minute. So since SQ is a perpendicular bisector and PS is equal to SR, can I conclude that PQ is equal to QR?
Yes, miss.
Yes, teacher. Yes, teacher.
Yes, PQ is equal to QR. So because it is perpendicular and cut it into two equal halves. What is the length of PQ?
3n minus 1.
Bravo. It will be 3n minus 1. And the QR, 5n.
5n minus 7.
5n minus 7. So let's use them here now in order to find n. So 3n minus 1, 5 and minus 7. They are equal. So let's say that minus 5n minus 5n. So negative 2n minus 1 equals to negative 7 plus 1 plus 1. So negative 2n is negative 6. So n will be 3. Now, after that, after we solve it here, what did we find? We find n. But what did he ask me? He asked me to find QR. So be careful if in the multiple choice, if you have the answers such as 3 or 14 or 12 as an example, which one we have to use? Or which one will be correct?
3.
Teacher will be 8.
And there's an 8. Okay. So which one will be correct?
8,
8.
teacher.
8. Bravo. So don't use n equal 3. Read the question. If I ask you what is the value of n, you tell me it's a 3. But if I ask you what is the length of the line segment QR, since QR is 5n minus 7, so here you will evaluate, well, 15 minus 7, which is 8. So the length of QR will be 8. And the length of PQ must be 8 too. Is it clear?
Yes,
Yes,
teacher.
teacher.
Clear.
Yes, teacher.
Okay. Now here. Use the figure at the right for the exercise 6 to 8. Here now, what is the relationship between MP and JK? MP
Bisectors.
and JK. What is the relation between them?
Teacher,
MB
MB
by 6 GK.
perpendicular to JK.
So the line segment MP is perpendicular to JK. So can say here that's so number 6. Just a second, please. So the line segment MB is perpendicular bisector of the line segment of JK. So number 7 now. What is the value of X? Since MB is perpendicular, so it's cut JK into 2 equal halves. So it means like if you have this line here, and you draw at 2 sides from that point to the end point, so it means like JM is equal to MK. Is it right? JM
Yes,
is equal to MK. So since they are equal, can I say that 9x minus 18 is equal to 3x?
yes.
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 It
So
will be
9x
6.
so minus 3x minus 3x. So 6x is 18. So x will be 3.
3.
So what's the value of x here? It's a 3. This is number 7. Now number 8. In number 8 here, they asked me to find JM. What is the length of the line segment JM? It is 9x minus 18.
18.
Do you know x?
Yes.
Yes,
Yes.
3.
So we will evaluate x here with 9 times 3 minus 18. Or we can say here, it's 27
Equal 9.
minus 18, which is 9. So the length of JM is 9. Is it clear?
Yes. So x equals 3 is the value of x.
Yeah. Number
Ah.
7, they asked me to find the value of x. And number 8, they asked me to find JM. Did you finish writing?
Yes, miss. Thank you so much.
Yes, teacher. Thank you.
Yeah. Now here, let's just, I will give you an introduction of the angle bisector theorem. Here in this theorem, they says that if the x or if QS bisects PQR, so SP will be perpendicular. And here means like this is a QS. Before that, I told you that this is the lesson here is a perpendicular bisector and angle bisector. Perpendicular bisector, it's cut the side into 2 equal halves. It cut the length into 2 equal halves. The angle bisector, it cut the angle into 2 equal halves. From its name, angle bisector. Now what the theorem here says, that if QS bisect the angle of PQR, and if you have the angle PQR, and there's a line, change the color, and there's a line here that's cut it into 2 equal halves. So that's mean from that point up to the line, oh yeah, I mean like S will be perpendicular on P and S will be perpendicular on R. So if the line here bisect the angle and S perpendicular on P and S perpendicular on R, so you will conclude that the length of SP will be equal to the length of SR. Tomorrow I will repeat it, just an introduction to what is the angle bisector.
Okay, thank you, teacher.
Okay, thank you so much.